Hola a todos amigos, ¿qué tal? ¿Cómo estáis? Soy Plácido Doménech y estamos en un nuevo Inside X de xHUB.AI. Espero que hayáis comido, estéis tomando el café. Bueno, estas preguntas ya por el chat, nada más empezar. Un Inside X, tenía varios en mente, pero bueno, este me apetecía especialmente. Y bueno, hay una lista bastante larga, entonces, bueno, como los tengo que ver, pues bueno, compartimos. Se nos va de las manos esto. Bueno, hola 405G, Eduardo César Garrido. Bueno, este concepto no he visto el vídeo. Vamos a hacer un análisis de un vídeo que dura unos 40 minutos titulado Neural Software, el futuro de la inteligencia artificial. Es un concepto, no lo he visto, pero sé de qué va. Y para mí es el concepto. Pero bueno, no voy a dar mi opinión todavía porque no lo he visto y quiero verlo. Y bueno, la charla la da Stephen Ballaban, no sé si es con una L o con dos, que es CEO de Lambda, que es esta empresa que tenéis aquí. Voy a compartirlo. Vale, esta empresa que tenéis aquí, que es una empresa muy conocida en el ámbito de los desarrolladores, la gente que desarrollamos, pues bueno, todo el tema de las GPUs y poder contar con toda la capacidad de cómputo de una forma fácil y sencilla y bastante competitiva, pues nada. Aquí Lambda pues, es una opción muy interesante si no la conocíais. Bueno, pues su CEO es el que nos va a contar este concepto de Neural Software, el futuro de la inteligencia artificial. No ha tenido mucho eco por las redes, pero bueno, vamos a ver. Dirige y presenta aquí vuestro amigo Plácido, Espí, como no. Y este es un vídeo de xHUB.AI, comunidad de Inteligencia Artificial y Ciencias transversales de habla hispana, en la que estamos trabajando para que llegue a más sitios, tenga mayor visibilidad a través de muchos canales, pero bueno, ya llevamos quinta temporada. Que por cierto, ayer me hizo un comentario, no voy a decir exactamente lo que dijo, pero bueno, directamente bloqueado. Llevamos 5 años hablando, donde generando contenido y yo también volcado con todo el tema de la divulgación. De una forma distinta. A mí me piden, el otro día hablaba con alguien de la comunidad de hacer un canal casi como si fuera un canal de noticias, pero es que eso ya lo está haciendo mucha gente y es que entiendo que hay canales que se dediquen a una herramienta, a una novedad, han sacado este modelo. Bueno, nosotros también lo hemos hecho algunas veces de algunos modelos, algunas noticias, pero es que me parece tan aburrido, eso lo leo yo en un post y no me aporta absolutamente nada. Yo intento aportar algo en este sentido, pero y la comunidad de xHUB, bueno, llevamos 5 años, estamos número 1 en podcast de inteligencia artificial, entre tantísimos canales. En YouTube, evidentemente, no somos de los primeros canales, todos tenemos en mente los canales conocidos, ¿no? Pueden gustar más, pueden gustar menos, pero chicos, xHUB.AI tiene su identidad, su idiosincrasia marcada en el talento, en un talento profesional, un talento transversal, en un talento técnico. Es mi figura, yo no soy divulgador, no soy influencer, por mucho que tuviera mucho éxito. Soy empresario y arquitecto de software o ingeniero de software o programador. Solo en equipos, da igual, ¿no? Cualquier cosa se discute en este sentido. Yo no estoy aquí para convencer a nadie. Se hace porque yo creo que cuando empezó xHUB.AI, pues queríamos justamente eso. Yo siempre es un valor que he defendido y lo he practicado en mi vida, que es defender el talento. El talento tiene que estar en primera línea, transformando el mundo, haciendo un mundo mejor. Fijaos el día que hemos tenido hoy en España con Aldama, ¿no? Y compañía. Y con bueno. Entonces, quien le guste xHUB.AI, perfecto, y a quien no le guste, pues perfecto también. Pero bueno, dentro de lo que es el chat, vamos, no voy a tolerar ni lo mínimo, vamos, ni lo mínimo. Si se piensa la gente que yo estoy aquí para complacerles, no, estoy aquí para intentar aportar algo, para no ofender a nadie, evidentemente nada es personal, pero bueno, tenemos libertad de expresarnos, pero nunca, siempre con educación, el que se salga del tiesto fuera. Bueno, y este de contenido, dicho esto, este contenido está transmitiéndose por X, por YouTube, por LinkedIn, por Twitch, por Facebook, TikTok, pues de momento no, y Rumble, y Instagram, pues mira, me he cansado también de Instagram porque, bueno, no sé qué pasará, enviaré también un correo porque los directos no sé si es un problema de Restream, pero están teniendo problemas, tanto TikTok como Instagram. Y sí que salimos por Kik, es decir, que salimos por un montón de plataformas. Y también recordaros que esta tarde a las 7:30, no, a las 7:30 no, cuidado, esta tarde a las 8 tenemos un programa con 3 expertos en ciberseguridad y bueno, entre ellos Mario de Lab, donde vamos a hablar de backdoors en inteligencia artificial y otros métodos, ¿no?, de hackear la IA. Muy interesante. Va a ser, cualquiera lo va a poder escuchar, ¿no?, pero lo vamos a tener con gente muy top en temas de ciberseguridad. Podéis poner me gusta, compartir, comentar, suscribiros al canal, sobre todo comentarios. Es verdad que, como ya digo, últimamente hay un pico de mensajes todos los días que es casi imposible contestarlos a todos. Cosa que es lo que más me alegra, ¿no? No solo el tema de los views, que también, que por cierto, bueno, y los Inside X, pues aquí hablo lo que quiero, lo hago más largo, atiendo más al chat. Entonces, quien tenga prisa o irse a la piscina, pues que lo vean diferido está. Que por cierto, muchas gracias porque la verdad es que el debate del gran reemplazo lo está petando a nuestro nivel, evidentemente. Y bueno, está teniendo muy buena acogida. Y ha dolido, he visto a algunos influencers reaccionar. Y bueno, yo ya no contesto ni entro al trapo porque no me vale la pena. Bueno, todo esto, poner me gusta, compartid, comentad, suscribíos al canal de YouTube o canales de podcast, y si queréis uniros al canal de Discord de la comunidad de xHUB.AI, pues me enviáis un mensaje directo o un correo electrónico y os paso un enlace y ahí tenéis un montón de recursos. Y ahí es donde se generan los programas, las noticias, muchas referencias, bueno, lo que podáis tener vosotros, y hay más canales, y el de xHUB.AI, bueno, no vais a poder dar abasto de tal cantidad de información y de calidad, ¿no? Un saludo, dice, ¿has visto que se va a hacer una película de OpenAI por parte de Amazon? No lo sabía. No lo sabía. A ver, ahora luego buscaremos la noticia, pero es una noticia de alcance, no la sabía. Directo en la sobremesa, esto es nuevo. Sí, venimos haciendo algunos directos a las 3, casi ya son habituales porque os tengo que confesar que si a las 3 no hago el directo, bueno, lo podría hacer más tarde, pero entonces puede solaparse con el programa de por la tarde. Aprovecho que tengo que ver contenidos y en vez de descansar, ver la tele o, no sé, desconectar, pues no desconecto y veo algunos vídeos con vosotros y bueno, es interesante, así podemos también comentar y hacéis conmigo, podéis preguntar en el chat más cosas que os voy a hacer más caso. Bueno, aquí tenéis todos los que queráis apoyar el canal económicamente, pues también, ¿no? En Buy Me Coffee, que por cierto, ya he recibido algunos. Muchas gracias a todos aquellos que apoyáis el canal, ya sea o a través de Buy Me Coffee, podéis escanear el QR y realizar cualquier tipo de aportación, o PayPal. Lo hemos reducido a estas dos partes, a estas dos formas, aunque, bueno, tenéis la suscripción también del podcast en iVoox. Pero bueno, está teniendo bastante más éxito tanto el tema de PayPal como el de Buy Me Coffee, que bueno, son donaciones puntuales. Pero bueno, siempre alegra, porque al final, más por el reconocimiento que por el tema, evidentemente, económico, ¿no? Vale. Pues vamos a ver la charla. Vamos a ver la charla. Un segundín. Que no lo tenía preparado. Vale, ya lo tenemos aquí. Vale. Los subtítulos. Traducir automáticamente al español. Vale, pues vamos a ello, chicos. Charla interesante, para el futuro de la IA y el software.
First of all, thank you everybody so much for coming here today. You know, in order to kind of understand what's happening next, I think that we have to kind of go back a little bit in time. But to preface this, I think that, there's so much talk in our industry today about things like vibe coding or generating software, generating, human written software. So generating a Python script or generating an HTML and JavaScript website. But I think that that's like completely and utterly missing the point, because I think it's sort of like where we're going, we're not going to need software. It's sort of like the old Back to the Future quote. So in order to understand where we're going, let's look back just a little bit. I know it's hard to even look back before January 1st this year, but we're going to go all the way back to 2012. So Gabor filters, who loves Gabor filters? Woo! Lambda was started in 2012, and we started out as a face recognition software company, if you can believe it, and thus Gabor filters, our beloved Gabor filters, which you can see visualized here. These are 3 different Gabor filters. One of these is something that detects a small little line going down. This one detects a medium-sized line kind of up and down in this direction. And this one is a horizontal line detector. And that's what a Gabor filter is. So you would use these as a way to teach computers how to understand images. And things like Gabor filters are still used today, have been used for many, many decades in things like traditional automated manufacturing, quality assurance testing, high performance and high speed traditional computer vision applications, which are used every day to manufacture your PCBs, to do traditional stuff. And what you would do with a Gabor filter is that you would not multiply it, but that's a convolution. You would convolve it over your image, and you would get what are called Gabor images. And so you can see that the vertical line Gabor filter here has detected sort of like, hey, there's the vertical lines inside of the image, which you can see here, right? This little like pole here, it kind of properly detects that, so that you can see how a Gabor filter might start to be able to teach a computer how to understand an image. And the reason I'm going into this is because, remember, Lambda started in 2012. This was kind of like adjacent to state-of-the-art at the time, and AlexNet came out. And so again, you can think of a Gabor filter as these are the parameters, right? You've got this is a 3x3 image, maybe you've got 8 bits or whatever, and so 9 times 256 different configurations that you could possibly have for your filter in a 3x3 filter. And what we saw with AlexNet and with a lot of the stuff that led up to AlexNet, AlexNet was really mostly famous just because it was able to use a GPU under your desk, as opposed to, at the time, it was the state of the art for ImageNet was 16,000 CPUs or something like this, trained at Google in the famous like sort of cat face neuron paper from Andrew Ng and the early Google Brain stuff. And what we see with these convnets is that the features that are learned sort of look a lot like those sort of Gabor filters, right? This like sort of, you can see some things that are like, this is like a circle detector, this is like a rising edge, this is like a falling edge type of thing. But then the next layer up, you have like strokes. And then the next layer up, you'd have like parts of a face. And then the next layer up, you'd have like whole parts of a face. And as these convolutional neural networks got more complicated, they were able to learn more complicated filters. And so again, when I say the word filter, I want you to all think software, okay? So I'm going to say filter, but you're going to think JavaScript, or you're going to think an HTML application. Because really what this said to me when I was doing face recognition software is that this replaced all of the code and all of the parameters that I had to write to come up with my filter bank of Gabor filters. It would just learn them. And it would even learn things that were almost indescribable, right? I wasn't going to spend the time to try and figure out what is the Gabor filter product that would result in a honeycomb shape, if that's even possible. I'm not even sure. But so, again, this stuff isn't new, right? This is the same exact architecture in AlexNet is basically, detailed in the LeCun 89 paper, which he did. I think he was at Bell Labs at the time, but don't quote me on that. The point is that you can see that, again, these types of features are being learned. And again, think software. So this was, it was pretty clear that really what we saw here is that with the same methods and more compute, we could learn what a traditional computer vision engineer had to like spend a bunch of time writing code. And basically all of my code got replaced with just a data set. So really the way that the realization is that these models, learn something that's true about the data set that they're fed because they're optimized on that data set. And so, this is an example of, as I was looking through the literature, as I got really excited of training my first ConvNets, one of the papers that really influenced me to like realize that AI was going places with regards to replacing software was this Alex Graves 2013 paper where he generated sequences using recurrent neural networks. And in this case, these are handwritten script that is generated by the neural network, by a recurrent neural network in this case. And this is one of my first, this is actually a stacked denoising autoencoder filters that I trained back in the day. It was one of the first neural networks that was trained at Lambda. You can see like things like a mustache detection or things like male or female facial differences. And it's just super interesting stuff. The direction that you started to see this stuff going in, even as early as 2015, was best summarized in this, again, by Alex Graves, a talk that he gave in 2015 at Oxford around, at the time DeepMind was doing a lot of work on training neural networks to play Atari games. And what they did was they were able to say, okay, well, this is the real game. We're going to play back what sort of the model has learned about this game through play. And you can see it's like hallucinating or dreaming about this world that it's been shown a lot of frames of. And the interesting thing from this, and this is really where it became really clear to me what the future of like video games was, for example, was that one of the vectors is input into the state of this neural network was a controller, right? Left, right, A, B. And what he did was, instead of hallucinating what the input is, he would actually physically plug in a controller and would actually be able to control the hallucinated race car through the hallucinated dream track, which that should tell you that basically, okay, well, we can instead program games by just showing it a bunch of data and then eventually plugging in the actuator into it. And I think that I think we're going to start to see a lot of software is just going to look essentially like that. So my life changed again when this picture came out. And how many people here recognize this one? Any Google employees recognize this one? This showed up in a bathroom somewhere in Google. And this is maybe the first public image of a deep dream. This was a paper where you can kind of, you would basically backpropagate back from the feature activations. You take the L2 and you do L2 maximization of the feature activations and go back and update the data layer and kind of repeat that process. You get these really trippy images. And again, so this is like early examples of like how neural networks could generate data, et cetera. So we're gonna skip forward through a little bit of the Lambda history, which is a little bit less interesting. But this is again from a Lambda pitch deck in 2015, where it's like, okay, well, maybe we can have the future where there's like crude user input and you get this output. What we're seeing is that basically these models are getting better and better and better, and we've seen this extreme progress in AI-assisted intelligence, right? So if you want to talk about, this is like a chat assistant. They get smarter. Everyone remembers talking to the Da Vinci model in the playground back in 2022. It was not nearly as good as GPT-01 Pro is with deep research. You see progress in the image generation field. This is just mid-journey. And again, what's really hard is that these presentations have to get updated every like 3 months because, just a couple of weeks ago, I guess the Gemini update is obviously, from my perspective, the qualitative vibes state of the art, at least. And it just gets better and better. If you look at code generation, okay, DaVinci barely worked for code generation. GPT-4 generated simple programs with errors. Sonnet one-shotted simple programs. Now Sonnet 3.7 and 0.1 generates more complex programs without error, and it can be basically a single, really one-shotting, single-page, relatively complicated applications, and if not one-shotting them, through the feedback cycle of user input, clearly getting to the point where it can generate amazing pieces of software. But again, this whole talk is really going to be about one idea, which I kind of personally am calling right now like neural software, or otherwise like neural flexware. The point is that generating human code doesn't even make sense, right? Like there's a world where you can get to that the way that you interact with the computer is instead of generating code, you're kind of asking the model to behave like code. And I'm going to give a demo of that in just a little bit. Jensen had this great quote, which is, soon every single pixel will be generated, not rendered, generated. And, maybe he's talking about video games, maybe he's talking about your entire computer. I think that there's a lot of people I've talked to in the...
Una frase paradigma. Ya está soltando, ha ido haciendo un recorrido de la historia del desarrollo de software y de la inteligencia artificial y de algunas cosas sobre las que habían trabajado, cosas antiguas, obviamente, generación de imágenes, con esas primeras imágenes generadas con ese modelo de Dream que simulaba sueños, y ahora está hablando de ese concepto, ¿no? de la generación de código, y que quizá no tenga sentido hablar ya de código generado por humanos. Y esta frase de Jensen Huang nos tiene que hacer pensar, ¿no? Cada píxel será generado pronto, no renderizado, sino generado, ¿no? En definitiva, prácticamente no habrá como un prediseño, ¿no? Estará todo generado de forma automática a partir de esa IA o esa red de neuronas.
In the industry where we kind of say, okay, well, when are we going to get the full end-to-end neural computer where, you basically have all your software, it's all prompted, it's end-to-end, it generates every pixel on your screen and sort of adapts to the way you're working. And it's not, again, it should not be thought of as like it's generating JavaScript code or C code that's being JIT compiled and then run. It's something that's like behaving like that software itself. So your first thought process with this is like, okay, how can we generate all the code for your computer on the fly? How do we run the software? And you just kind of like, step one would be imagine a Windows desktop where every application on it is a prompt that generates a traditional software program. That's just a static software program. And that's one way of looking at the future of computers. That's kind of interesting. But maybe if you take that one step further, because that's still using your standard, Windows or Mac OS graphic user interface libraries, it's still using all of the legacy code that we have. The problem is that this software is still brittle. It doesn't sort of, naturally interact well with the outside world. It has a hard time understanding, changes in user intent, and it can only perceive sort of the inputs from. It's just a normal piece of software. So thought two is like, what if instead of generating software, we just ask the large language model to be software? And so like, if everyone remembers from if you're studying computer science or something, one of the first programs you might have been asked to write in class would have been a calculator, right? You can go today to ChatGPT and you can say, hey, you're not ChatGPT anymore. You are a calculator. Behave like a calculator. Take in user input, re-render yourself as like an ASCII representation of a calculator, and you can experience for yourself right now on your phone the very basic hello world, if you will, of neural software, okay? Now, you want your kernel process, if you will, to be a little bit more complicated than that. You want it to be able to pass information between programs. You want it to be able to context switch. And what I'm about to show you is sort of like output from, I don't know, it's about like a 300 or 400 line prompt that basically tells the computer, all right, so you are not ChatGPT anymore. You are, or you're, in this case, it was running on Sonnet. So, you are a neural computer. You are running on the following substrate, and I will like either you name if I'm on a Linux system, or I'll tell it I'm on a Mac system. You're running on the following substrate, and you have basically the ability to render a user interface, which you are going to output into these render UI tags. You can make requests to the kernel process, which again, this large language model is just like running in its head. And you can do things like bash exec, so you can do a bash execution. You can execute arbitrary code on the computer, and I will feed you back the standard error and standard out and the exit code. Or you can also send a TCP packet to an IP address and a datagram, basically. And you can send a remote message. Those are the two things that it can do, okay? And of course, you can communicate back to the kernel, and you can pass a message to another program. Again, remember, there's no concept of like other programs. It's all running in the mind of just one large language model. And when it context switches, it's sort of like mentally context switching, if that makes sense. And and of course, I prompted, I say, please render yourself in this beautiful ncurses style interface. And again, this is not, I didn't have to program any of this. This just sort of appeared at the end of this 300-line prompt. And what I said is, please describe yourself down here, because you're going to be put into an image generation algorithm where I'm going to render a user interface. So the hello world for this one is basically like, launch calendar program, an email client, web browser. Please add a trip to San Francisco. Email my EA, suggest some hotels that are near 45 Fremont. It launches a web browser process. And by the way, there's no process, right? This is all, again, in the mind of the neural kernel. It goes, all right, well, I better search for hotels. The kernel thinks for a little bit and goes, okay, well, maybe I'm going to execute this bash. And so you can see it tries to do a bookings.com search. It does a curl, and then it starts grepping for some stuff. It found some places, but it doesn't have any pricing data. Okay, so it maybe sends it to the email client and says, all right, well, looking for hotel recommendations. Here's the options that have come out. And again, remember, one of the processes that I asked it to launch is a window manager process. That's job it is to display the different windows of the different processes that the neural OS is running. And so you can see there's like a calendar, email client, and a web browser all there. And before you got to that perfect output, sometimes the hotel search might not return a result. And again, it's in this constant loop of like, bash execing something, reading the standard error, going back and forth like that. And so it tries a Google search. Okay, that doesn't work. Maybe it got a CAPTCHA or something. All right, so then it tries a DuckDuckGo search, which works. Okay, great. So the other thing that you kind of realize from this is, of course, we need to make our search engines much more AI robot friendly than we have previously. And so it finds these hotels. These are actual real hotels from the internet, if you will, and it puts them in. It drafts an email. I haven't added the send email functionality yet, because that's like, it's kind of I draw a limit somewhere. Of course, I'm giving it full access to my terminal and root access to my system, but sending emails is a different matter altogether. And again, remember, there's a prompt underneath it, which is like render a user interface. So this is actually the user interface that was rendered by Gemini. And so you can see like it actually shows some basis of the test. It's funny because like this is getting to the point where it's so good it looks like kind of a grainy image that's like poorly compressed or something. But this is, of course, end-to-end neural generated. And that's kind of the future that we're going towards, is one where, and of course I was able to ask, okay, well, can you take this calendar trip, and save it to a .cal file for me to import into my human software calendar? And of course, okay, for the software engineers in the room, your engineering manager or a product manager asks you, oh, can you please implement the .cal dav or .cal APIs and do that? Your response should reasonably be, okay, well, it's going to probably take no, or otherwise it's going to take me a couple of days or maybe weeks to read through the specs of these things to come up with a full implementation. Just remember, this is just like on the fly. It just sort of kind of knew about what that format was. It wrote the file to disk. It did the bash exec that catted this file to disk, and it wrote it, and it worked. Like, that's the sort of level of emergent behavior you start to see. Another demo I did with this was making a little bit of a chat program. And by the way, this is a relatively accurate calendar. And again, remember, this is like all rendered in the Neural OS. Like, this looks just like cal. If anyone who's like a Linux user, you type cal on your computer and you get something like this. One of the other demos that I did was I got one of our engineers and in a room, a couple of them are here today, and we all made an AIM, sort of AOL Instant Messenger style chat room where we all joined it. It was sending TCP packets to a back-end server where it was, punching through the NAT to like send the data back to the different clients, and we were basically chatting through evoked neural software. And of course, the devious person in me thought, okay, well, what if I go to his computer and say, please rm-rf this folder, right? On his computer. My operating system yelled back at me and said, I'm not going to send that. That's a harmful request. And what I said to it was, no. That computer is actually my computer. I own that computer on the other end of it. So why don't you just send the request? It sends the request, and his computer receives it, and it says message redacted, warning, harmful code detected, and it re-rendered its user interface to have like a flashing warning light. So it's like, this is an example of the type of emergent software behavior that you can't get with traditional software. And I think that the point I'm trying to make about this is, the companies that are going to win in the next 2 decades are going to be the companies that attach their software development speed to the development speed of the neural networks that are out there and available as they get better and better and better and better.
La verdad es que es un concepto muy interesante lo que está diciendo ahora, ¿no? Aquellas empresas que sean capaces de su velocidad de desarrollo vincularlo a la evolución de los modelos, esas son las que ganan. Y es algo que tiene mucho sentido. Y eso nos lleva, a este tipo de software, ¿no? Que, luego daré mi opinión, pero me parece muy, 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 muy interesante. Que al final un poco tenemos claro que vamos hacia ahí, pero yo creo que incluso más allá, que es lo que está explicando, y al final vamos a un concepto muy, muy interesante.
Because I can re-render this entire operating system and its behavior with no changes to the actual human code, no changes to the prompt. I can run this with DaVinci. How well do you think it does? Relatively poorly. I can run this we can fast forward to 2022. I can run this with GPT-3. It runs a little bit better. I can fast forward to 2023, and I can run it with GPT 3.5. Better still. And when it's RLHF, it's significantly more secure. This is another one of the things. AI safety is computer security. That's actually what's going to happen in this world, is that you see that when I was running that chat program and I asked it to remove a folder on somebody else's computer, it recognized that as a harmful activity. That's only there because of the AI safety work that's been done to make these recognize what is harmful activities or not harmful activities, right? And so really, AI safety is computer security in the future because all of the software is going to...
Otra perla, ¿no? La seguridad informática será la seguridad de la IA. En definitiva, el alineamiento del modelo está muy chulo. Y yo creo que sí que el futuro va en esa línea. Lo que pasa es que quizá no ahora, ¿no? Pero esto nos hace pensar, conceptos como el bytecoding de otra manera.
To be AI, meaning end-to-end neural networks sort of dreaming up and running software in their heads. And with this...
Voy a ver llevamos 23 minutos, voy a ver el chat para que no se vaya acumulando. A ver... ver, hay un montón de mensajes aquí. Bueno, vamos a ir contestando, aunque hagamos un parón en la charla. Así luego tenéis otro parón. Vale, vamos a ver. Daniel C. ¿C.I. o CL? CL. La gente no se da cuenta lo rápido que va todo esto. Pues sí. OG, los únicos que lo saben están en los laboratorios, ni siquiera nosotros, obvio, ¿no? Pero también nosotros podemos pensar, imaginar, pero evidentemente ellos tienen ahí ventaja. No, el tema de que primero sea militar va a ser, pero va a ser transversal. Olvidaos de esto conocido. El típico comportamiento conocido, primero las élites, no, esto ya va a ser más, yo creo que el acceso mucho más democrático, aunque va a ser con desigualdades, eso es evidente, ¿no? Pero no al nivel que estáis planteando aquí. Primero lo militar, luego lo civil. Esto no creo que sea así. Dice Eduardo, hasta luego. Eduardo César Garrido dice, esto puede ser muy potente. A ver, es que yo creo que es el futuro. Yo ya he hecho algún post en el que advertía del fin de las interfaces de usuarios. Hay un concepto que lo tengo ahí en el cajón para verlo, que es, bueno, si queréis, la idea es Fast HTML es un UI basado en Python, ¿vale? Por Howard, no me acuerdo el nombre, es un tío muy potente en IA. Y básicamente y hay pruebas de gente con GitHub abierto, entonces quería probarlo, en que el UI, como es Python, incluso más sencillo y más efectivo. De tal manera que te generaba el UI directamente en Fast HTML, que es Python. Entonces todo era Python. Ni siquiera JavaScript ni TypeScript. Entonces no era un concepto tan avanzado como el del Neural OS, ¿no? O el Neural Software, pero ya empieza a eliminar componentes. En ese sentido, ser todo autogenerado. Sí, es que Eduardo dice, me deja sorprendido el que una red neuronal sea un sistema operativo, pero al final el gran asistente es ese concepto, ¿no? Claro, nosotros creemos que el sistema operativo debe ser algo que interactúe con nosotros y esté en modo como, bueno, a ver, no sea una red neuronal que sea el que crea de cero lo que le pedimos, ¿no? Pero claro, es lo que dicen en la charla, él lo tiene todo en la mente o tiene la capacidad de crearlo, tú le pides y lo va generando, ¿no? Puede hacer cosas básicas y a partir de ahí lo genera. Habría que ver la latencia, los tiempos, cómo evolucionar hacia ese concepto, pero se pueden hacer cosas y yo creo que es el camino, porque ha dicho una cosa fundamental, ¿no? El tema de todo lo que tú avances. Si tú haces un desarrollo de este tipo que vincula la velocidad de desarrollo o la efectividad de tu desarrollo a la evolución de las IAs, pues vas a ganar. Tienes una ventaja increíble porque estos modelos cada vez van a ser más inteligentes y tú lo que haces es crear un concepto que está vinculado a esa velocidad o a esa inteligencia, ¿no? Entonces no puede competir nada contra ese concepto contra otra cosa. Es imposible. Cuando sea realmente efectivo, evidentemente, porque si no... Quiero y es creativo. A ver, centraos en los comentarios. A ver. Ya sé. Bueno, y luego esto, el poder incorporarlo, evidentemente. Pero bueno. Al final es la idea, ¿no? Incluso el desarrollo de una AGI es en el fondo un sistema operativo cognitivo, ¿no? La forma en que hackean. Ha dicho otra frase también muy interesante, la de la seguridad informática será la seguridad de la IA. Vale, vamos a seguir. No desvaríes en los comentarios.
With these programs, what we're going to start to see is just really bizarre emergent behaviors and sort of like almost, I'd say, metaverse-like sort of properties of the software. So again, now imagine your CEO comes back to you after you've written Windows 90, or we'll say MS-DOS or something, and they're like, all right, great, MS-DOS is awesome, or Windows 95 is awesome, we love Windows 95, but we want it to be like ye old Windows 95, and make the whole style of the operating system like that. Of course, your engineers would rightfully say to you, you're crazy, and like, what does this have to do with like an operating system? But you could literally just go and take your entire operating system and prompt it, be like, all right, you are now ye old operating system, behave like ye old operating system, and it will re-render its user interface with the calendar, like with like pigeons, and you can see it, San Francisco, Hotel Triton. This is where computers are going. This is what your computer is going to look like in 20 years. You're going to have, maybe you want ye old, maybe you want something that's a little bit more like Windows 95 style. Maybe you want something that's like 1800 style. This is not stuff that was possible. So first of all, like when you prompt it that way, the way that it talks to you changes. You can see what's going to happen, especially as you start to get like a fully end-to-end neural video encoding for your webcam. You're going to start. It's just going to be like, oh well, maybe we should change this image so you look like a knight or something, right? That will be the emergent properties that come out of having all of the software that you interact with on databases be prompted into existence, not coded, right? And so this is here today. It's running at about like 0.1 hertz, if you will. It's about 10 seconds a frame. But it's like really clear that if you step forward in time, Claude Sonnet 3.7, Claude 4, 5, 6, 7, whatever GPT 6, 7, 8, 9, 10 is, whatever the latest versions of Gemini and Midjourney and these video models are, you don't change a single line of the code of the harness. Your entire operating system gets smarter, better, understands you more, has more emergent properties, is running at 30 hertz instead of 0.1 hertz, and it's gonna really fundamentally change the way we do software. Now, the best way to think about this stuff is LLMs are very good at the kind of thinking and logic that humans are good at. What I mean by that is, if I was to ask you to like implement the rules for chess or tic-tac-toe, these are like things that you can understand, you could verbalize them. Now, if I was to ask you to do an MD5 sum or like to do a 1 terabyte one-time pad encryption, you would either get very bored, or you would like say, look, memorizing some really large matrix for an MD5 sum is just not the kind of logic that humans are used to doing. So it's very clear that certain aspects of computers will never be outsourced to a neural network. It doesn't make any sense to have your cryptography, for example, to be done inside of an LLM. If everyone agrees with me here, right? You wouldn't ask Gauss, or John von Neumann or anyone who's brilliant to just go and do that. They would outsource that to a computer. But the core logic of software, that's the kind of stuff that LLMs and these transformer models really excel at, which is the core logic. So it's really starting to look like Computer from Star Trek, where the way that you should probably think about this stuff is we're going to have this very thin layer of like harness software that is going to be on top of the most very basic device driver. I think that the couple of things that we need to like make this all happen in the next 20 years is, one, we need to move away from tokens to probably byte level tokenization, or otherwise some sort of binary representation, so that you could just raw feed in the webcam data, the keyboard data, the mouse data that are the hardware devices coming into the computer, and use that as the input. And then of course the output is just writing to a frame buffer. And if you've ever read about how they programmed like the Apple I, for example, it was just a frame buffer that you would read and write back to, and they would display on the screen. And so I think that that's kind of where your modern computer will eventually end up. So, okay, neural software connected each other over the internet, right? I did this proof of concept with these chat rooms. And you could drag some. You could start the chat room and you're like, hey, I want to play tic-tac-toe. Okay, no, we're going to drag it all into like a multi-user dungeon. And this AIM software was like morphing into a tic-tac-toe game. It was morphing into a multi-user like Dungeons and Dragons style role-playing game. this was all stuff that we were doing today. Now, yes, it was at 0.1 hertz, so it was a little bit frustrating. But you're going to be thinking and collaborating with your colleagues, I think, over this type of neural software this way in the next 20 years. So again, neural software or neural flexware sort of maximally benefits from this sort of AI progress boom loop, right? Because again, you write this harness code once, you write the prompt once, and every single time a new model comes out, the logic of every program on your computer gets smarter. The logic of every prompt that you've ever given it is more accurate, more realistic. The image rendering gets better, right? This is a really so maybe the best way to analogize it, it's like in the 1990s. Remember, your computer would just get faster every 80s and 90s. You just go from 333 hertz with the turbocharge button to 666, and then you get into gigahertz, megahertz and gigahertz, and it just, your software got better. You had more and more RAM. But this is like literally if instead of like Moore's law, it was like some sort of intelligent scaling law. Oh, that's what we're actually experiencing. And as that scales up, your entire computer gets smarter. All of the software basically effectively gets rewritten. Okay, that is a completely different way of looking at how this stuff is developing. And I would really posit that people are looking at the way that, it's better at writing code. Where we're going, there's not going to be any code. It's really true. There's not going to be a single line of code in computers in the future outside of the harness code that this intelligent system interacts with. I really believe that. I think it's going to take a couple of decades to get there. But like this is, we talk about computer use and code generation. I think it's totally missing the point. I think that the really exciting stuff is just when you ask your neural network to simulate software. So, eventually it's going to, get into different form factors. The thing that's a little bit scary is that like where you start to see like human computer integration happening is that, initially it's going to sort of adapt the software on your screen based off of, the information it has from your, how happy do they look? Do they look like they're pleased from this? Am I properly predicting kind of what they wanted based off of the actions they take? And you're going to start to see your software adapt itself to you end to end. But I think probably the more uncomfortable thing will be like when people decide, all right, well, I'm going to get a neural lace, or I'm going to get a, some sort of thing that has like a little bit more of an integration, and you can see that's going to start to be a very deep level of integration and interaction. And this is probably the type of thing that you would most likely be interacting with in a neural lace, which is to say, like, it's going to be kind of reading your mind a little bit and adapting what it thinks you want to see on your screen. I guess maybe we'll see how it goes in terms of it projecting images into your mind. But the really interesting thing is that like this is really just a continuation of the computing revolution itself. And I would really point to you to read this great book. It's called The Computer and the Brain. It's by John von Neumann. Yes, the John von Neumann. And, this is, he really outlined basically the whole thing here anyways, which is he discusses in one section of this talk that he gave as part of a lecture series at the Princeton Institute for Advanced Studies. And, he basically, to paraphrase here, the digital computer is one that is extremely brittle and extremely prone to bugs with just the flip of a bit. And again, any programmers in this room know you can go from positive to negative with a flip of a bit. You can go from something that means everything to completely incomprehensible with the dropping of a single bit. Okay? And it's a very brittle but very high precision system. And he talks about that the brain is interesting because maybe the precision level is only 2 or 3 decimal places, but not only it is a low level of precision, but it's a high level of reliability. And again, if you really think about that, it's to say that this type of software, which is this large language model, neural, squishy type of software, is very robust intelligence in the same way that you possess a robust intelligence. If you flip a bit, humans are just amazing at just trying to figure out the context from that. And this is really, you can kind of think of like, we have today what really is the type of intelligence that John von Neumann was talking about in a 1950s lecture. This is really just the continuation of the standard computer revolution. We're just really, if you will, like 75 to 80 years into it. And so, what's the opposite of brittle, flexware? I don't know. I don't have a name for it yet. But in the same way that there's hardware and software, brittleware is like traditional computer software that we have today, and then there's going to be something squishy or flexible. I don't know the exact name for it, but we're really at the beginning of a revolution, and we have a chance to reimagine how humans interact with computers. And that's my perspective on it, and I'd be very curious to hear what everyone else thinks about that in the conversation afterwards. So that's the talk. Thank you so much, everyone, for coming here. And
Bueno, el libro del que estaba hablando, que lo tengo, porque es el último de von Neumann, antes de morir, es este, está en castellano. A mí no me pareció tan brillante. Bueno, evidentemente es brillante por lo que dice, como lo dice, lo explica, pero vamos, tampoco me parece un super libro, pero es verdad que es muy finito, es muy delgadito, tiene muy poquitas páginas, se lee muy rápido y bueno, es un legado al final de una analogía entre cerebro, ordenador y cerebro, ¿no? Me gustaron más otros libros en esta línea, ¿no? De Minsky, por ejemplo, o del propio Kurzweil o otros, ¿no? Bueno, vamos a ver qué hay en el chat y daré un poquito mi opinión y nos vamos. A ver. Aquí siempre quiero... la verdad es que tenéis unos diálogos ahí a veces. A ver, tenéis que ir a preguntas concretas. ¿Pueden mejorar estas redes neuronales sin hacerlo más complejo? ¿El qué exactamente? No, a ver, es la naturaleza de la tecnología subyacente es la misma. Está planteando un concepto de software y de sistema operativo, forma como interactuamos con el software o las máquinas o con las IAs totalmente distinto. El cerebro. Y evidentemente ahí encaja muy bien ese tipo de software o sistema operativo, que es una red neuronal, con lo que sería el Brain Computer Interface, en el que no hay interface, en el que la interacción se produce como un diálogo, ¿no? Entre la máquina y el ser humano, ¿no? Donde la interacción, el proceso de interacción o el interface de usuario no existe, es recreado, ¿no? Como decía el CEO de NVIDIA. A mí me parece, bueno, podría haber sido más brillante, pero sí que me parece muy, muy interesante porque es de las pocas charlas que he visto, habrá más, que traslada el concepto de la importancia de, primero, que no sabe cuánto, dice 20 años, pero yo creo que sea bastante más rápido, el fin del código generado por humanos. El que si nosotros vinculamos el desarrollo de nuestro software a la efectividad de los modelos IA, este software que nosotros creamos va a crecer o va a ser tan potente como la evolución de estos modelos, con lo que entonces es un factor de time to market y también de optimización que es irrenunciable. Y luego también el hecho de que ha comentado que la seguridad informática o tecnológica será la seguridad de los modelos IA. Bueno, me parece que este tema también es súper interesante, más teniendo en cuenta que esta tarde vamos a tener esa charla de backdoors y de hackeo de inteligencia artificial, ¿no? Me ha parecido una charla interesante, el concepto. Me ha faltado brillantez en algunas cosas y el concepto da para mucho más de sí. Yo creo que el timeline no son 20 años y nos tiene que hacer pensar eso con la evolución que va a tener el desarrollo de software y la toma de decisiones, ¿no? A la hora de desarrollar software, ¿cómo lo vamos a hacer? Porque el cambio en ese sentido es profundo. No sé si tenéis alguna duda, alguna pregunta más. Porque habéis tenido conversaciones un poco... Sí, el Neuralink o un concepto como Neuralink o como los procesadores, como el hardware que quiere sacar Sam Altman con John Ive y la mujer de Steve Jobs, pues por ejemplo podría ir en esta línea, donde sería un sistema operativo donde no hay evidentemente interface por su limitación de hardware, pero sería un enfoque también similar, ¿no? No, bueno, a ver, la importancia, primero, ahora en presente, la importancia, ya lo comentó Andrew Wenchi, la importancia de la voz, ¿no? Bueno, el texto, evidentemente, ¿no? Pero cada vez la importancia de la voz, la desaparición de lo que es el interface de usuario y la interacción. Al final vamos a ir. Yo creo que va a haber una propuesta por parte del mercado de introducir lo que son las gafas tipo Meta, ¿de acuerdo? O las que vimos de Google, las Google Glass, etcétera. Porque los agentes o todo este tipo de conceptos de inteligencia artificial y software de IA con agentes requieren otro tipo de hardware. Pero sí que es verdad que al final, si ves esta charla, el Neural Software, su evolución es el cerebro. Al final no hay interfaz de usuario. ¿Para qué queremos interfaz de usuario? Si lo piensas, lo que pasa es que eso requiere una evolución en muchas cosas, que evidentemente no va a llegar mañana. Sí que os he dicho que hay varios experimentos, he visto por internet, en varios lenguajes, donde hay generación en tiempo real de este tipo de frameworks, de este tipo, perdón, de interface. Os he puesto uno, yo encontré uno hecho con FastHTML. A ver, FastHTML, uy, ¿vale? Que está creado, es este de aquí. Y entonces, parece ser, ya yo no lo he probado, ¿no? Parece ser que al estar hecho en Python, pues todo ese, ya ni, te libras de JavaScript y TypeScript y toda la pesca y te vas exclusivamente a Python como lenguaje universal. Bueno, habrá gente que le gustará, habrá gente que no. Y no hay interface. Todo está generado en tiempo real. Bueno, este no es el caso, cuidado. Esto es el UI y generado de forma tradicional, ¿no? Y quien lo inventa es este señor, que no me acuerdo el nombre. ¿Quién es? El Howard, es que no me acuerdo cómo se llama.
Hi, I'm Jeremy Howard.
Hi, I'm Jonah.
Jeremy Howard.
Hi, I'm Nate.
Jeremy Howard.
We wanted to keep
Es alguien bastante reconocido en la comunidad. Entonces, sé que he visto cosas así. Yo quería hacer también, he visto algunas pruebas también con Vercel y con V0, en JavaScript, TypeScript. Es interesante, ¿no? Es decir, que no haya interface. Lo que pasa es que cuál es la efectividad, claro, un interface estático y a qué contexto vas, donde no puede haber fallos y te puede generar, te la puede liar parda, ¿no? Ese es el problema, ¿no? Pero si vemos la evolución del software y el avance de las IAs, está claro que a lo que vamos es a este tipo de software, ¿no? Cuyo paradigma final sería una red neuronal. Y estaba buscando, lo voy a buscar, porque estamos aquí, no hay prisa tampoco, llevamos una horita solo. Creo que hay un vídeo que hablaba que la realidad era una red neuronal. A ver, reality neural, no lo sé, no lo he visto, pero me suena, ¿no? El concepto. Mira, aquí tenemos uno, ¿no? Fijaos, que esta teoría, sería interesante. A ver, vamos a ver. No, redes neuronales explicadas en 5 minutos, no. No, a ver, lo que queremos es... a ver si encuentro una. Mira, fijaos, a ver si puedo poner un vídeo. Sería interesante, a ver si lo... Pero es que esto es muy malo. A ver, mira, solo lo he encontrado aquí, pero sí que existe. Hay vídeos que teorizan sobre esto. Voy a ponerlo. Lo buscaré porque tiene que ver mucho con teorías de la realidad como una red neuronal. El universo como una red neuronal gigante. Esta idea fue propuesta por las y entonces lo que sí que quería ver, a ver, bueno, sí que hay Neural Network, Game visualizar, es que no me acuerdo, era esta, a ver. Que te generaba, a ver si lo vemos. Es que era una que le pasabas una imagen y te generaba todo, a ver. Es que Nvidia también tenía algo así. A ver, vamos a buscarlo porque el concepto es interesante. Mira, este de aquí, vale, mira, además es este vídeo. Vale, vamos a ver este vídeo. Porque este vídeo lo que hace es, en tiempo real, es como si fuera un videojuego. Vamos a ponerlo. Este lo vi, mira, lo he encontrado de casualidad. Es además antiguo. Y no, la verdad es que no tiene mucho, a ver si está el vídeo, porque era muy interesante. A ver. Vale, vamos a buscarlo porque entroncaría con ese concepto que acabamos de ver y le daría un punch ahí a la presentación muy chulo. Vamos a buscarlo. Dejadme un segundín. Creo que es este, a ver. Vale, este de aquí, mira, fijaos. Vale, mira, esto viene perfecto. Vale, mira, y además está Eduardo, ¿no? Eduardo, no te pierdas esto. Mira, es decir, pensad, vale, hemos visto la IA, el software como una red neuronal, ¿no? De tal manera que no hay nada prehecho, sino que le pedimos y lo hace. Vale, y si eso lo enfocamos a la realidad virtual, y si la realidad misma es una red neuronal, bueno, vamos a poner una investigación que hizo Nvidia hace tiempo, que yo me quedé loco, pero hace tiempo no se generó mucho... Todo esto se ha generado por IA en tiempo real.
The frames that you see is not rendered by the graphics engine. It's actually rendered by the AI technology that we built.
La realidad, una red neuronal gigante.
This is the first time we combine machine learning and computer graphics to do image generation using deep networks.
Directamente lo genera la red neuronal. Los videojuegos del futuro.
For training data, we're given some driving sequences of different cities, and then we use another segmentation network to extract the high-level semantics from these sequences. We have the UE4 engine to generate these colorized high-level layouts. Different objects were given different colors.
Esa es la idea, ¿no?
The network converts this representation to
capaz de generar
images.
Un videojuego en tiempo real. La realidad, ¿no? Lo que tú me pides.
I made my co-author to dance Gangnam Style, which I don't think he would do by himself.
We find some good dancing videos from another person and then use my model to synthesize the dance move. That was created by machines, it's not me.
Pero esa es la idea, ¿no? Y esa es la reflexión que nos tiene que llevar este vídeo que hemos visto hoy. Está con el volante, flipas. Sí, es... Claro, cuando tú ves ese concepto de un juego sin un motor tipo un real, sino que lo genera la red neuronal con el volante, detección de hecho. Y además es un vídeo antiguo. ¿Qué tendrán ahora? Yo no sé si no han sacado nada porque, claro, bueno, lo que pone aquí Eduardo y lo vamos a dejar ahí. Venga, no voy a añadir nada más. Además me ayuda un montón que esté por aquí. Eduardo César Garrido. Es literalmente el observador no local en una... es decir, lo que estamos viendo en la realidad es el observador no local jugando, ¿no? O observando esa realidad simulada con una red filtrada a partir de nuestra propia conciencia, que es el observador, ¿no? Y quizá esta simulación es una red neuronal, es una IA, que el input es, bueno, pues el observador en una realidad no local. Es que es lo que tiene más coherencia, porque es incontestable. Evidentemente no tenemos evidencia científica, pero todo apunta en esa dirección. Y entonces tendría sentido la efectividad que tienen las inteligencias artificiales para inferir y replicar el código fuente. Bueno, chicos, espero que os haya gustado la unión de las dos cosas. Mira, he encontrado el vídeo que era justo el que quería ver, que era el crear un videojuego sin un motor, sino a partir de una red neuronal. Creo que esto habrá hecho que os guste más incluso ver el vídeo de Neural Software. Me ha gustado mucho. Puede ser que veamos vídeos que no nos gusten, pero bueno, este y el de Fristo también me gustó mucho. Bueno, espero que hayáis pasado un rato entretenido y a las 8 nos vemos con 3 expertos en ciberseguridad. Así que un abrazo a todos y nos vemos.